you did take this weekend to look over your section 2.5 because you weren't ready on Friday, and if you know that you have a question or two, go ahead and open up your spiral. However, for the rest of you guys, actually for all of you, let's go ahead and go to our workspace. We are going to do just 3 questions from section 2.5 because Friday was a little rough. Either you didn't have the homework ready for whatever reason, or there were lots of questions and it was hard to make it match. So I have 3 multiple choice from section 2.5. I want you guys to try them. But I wouldn't necessarily start collaborating in your groups right away. You are allowed to reach out. That's totally fine. So I wouldn't start collaborating. I would start seeing if you could start each problem on your own first. This is 2.5, APMC, AP multiple choice practice. I want to see how we do on this, but if you did go over section 2.5 some more over the weekend, trying to grade, trying to figure out the ones that you had gotten wrong, etc. And if you do have a question, have that ready, because in just a second, after we do the workspace, I will go ahead and ask if there are any questions that you want us to go over. Not in great detail, but I'll try to answer whatever I can. Otherwise, we'll go ahead and go into section 2.6. Ideally, on multiple choice, you want to spend about a minute, minute and a half. So let's say 4 minutes. I'll have you guys checking your groups in about 3. Pause real quick. In 84 and 85, are you using the product rule? Mm-hmm. If not, double check, reassess. There is a times. The product rule is needed in some, at least one part of each of those. Okay, sorry, go back. All right, if you haven't checked in your groups yet, you guys have been working. I'm not saying it to be totally done, but go ahead and talk it out a little bit.
Thing on base.
I didn't
Showing so slow.
Still, I just started 86. I'm slow as well.
I know.
Oh, I don't know.
Wait, why'd you do it
Already
before?
trust me. I just started 86 though.
Oh, yeah.
You guys ready?
No.
Okay. So I can start. Slowly. I'll go ahead and orient. That'll give you guys a couple more seconds. Alright, I'll work quietly. Some of you guys are still trying to finish. But just real quick, how many of you guys think you at least made one match? Good. How many of you guys think you made at least two? Okay. Pretty confident on it? 3. Okay.
Not there yet.
Not to
That's okay. That's okay. Keep going. The second derivative takes a little longer, I understand. You guys know implicit, take a derivative of both sides, right? Whatever's the product rule on number 85? Do you guys see that? Yeah, the x squared y, right? Now, I like making the negative a part of my product rule. But if you didn't, you just would have distributed. That's an x squared, right? Yeah.
Oh, because you got to move for the light.
I have a quick question for you on 85. Are we eventually plugging in?
Yes.
Do we have to get dy dx alone before you plug in?
No.
Yes.
No.
Yes.
Technically not. Now, sometimes it might be easier to get dy dx alone, but do you guys realize if I plug in a number, isn't that just a number plus a number plus a number times dy dx plus a number? It might have been easier just to plug in right away. It's multiple choice, you're just making it match. What I mean is, if you were to plug in 1 right now, 4 times 1 cubed is just 4, right?
Mhm.
And then 1 times -2 times 1, isn't that just -2? And then -1 squared, well, sorry, 1 squared, 1 times a negative, that'd be negative dy dx, or minus dy dx. And then 1 cubed times 4, that'd just be 4 dy dx. It might have made your life easier, faster. Does that make sense? Because now I can just do 4 minus 2 is 2, and then combine like terms, -1 plus 4 would be 3 dy dx. Subtract the 2, divide the 3. Oh my goodness, another b.
Yep. This one's right. See.
I know not everyone got to number 86. Let's pause. Any questions on 84 and 85?
Actually.
Did you follow my rule? Remember, implicit differentiation, whenever you take the derivative of something like ln of y up here, I did second d first, that's just the beginning of the product rule. But then I did first d second, the derivative of ln of y is 1 over y times y prime, right? 1 over y times y prime. Remember, the derivative of any constant is 0. Super simple mistake, but it's so easy to make. To accidentally put the 1 or to accidentally put the 2, and I bet sometimes that's one of the answer choices.
6 times 6 times 6. Wait.
218?
Maybe?
I think so.
60.
Okay, so we're okay for me to go to 86, are you sure?
Yeah.
Okay.
66.
Number 86, how bad was the first derivative?
No.
Pretty good.
It was nice.
Not too bad, because it was hopefully 2x plus 2y dy dx equals 0. Careful, not 100. Derivative of 100 is 0. So then when you guys solve, getting dy dx alone, did you get negative? Was it negative x over 1?
Yeah.
It was.
Oh yeah, because you.
Subtract the 2x and divide the 2y. Does that make sense?
Oh my god.
Yeah.
However, what do they want? The
Second.
second derivative, so we gotta go again.
Quotient.
So then we could go ahead and take the derivative of this side, which would be d squared y over dx squared. And we could do quotient. Bottom d top minus top d bottom. What's the derivative of y? dy dx, or 1 dy dx. All over bottom squared. Okay, help. Second derivative. This is super crucial. The part that everyone forgets. What do I do before simplifying? Who is this guy? Plug it in. Right? We gotta plug in dy dx. Huh?
That's where I got running homework.
Yeah. It's so easy to get that part wrong. Like it's one of those, like it's in our steps and we talked about it, but for some reason it just kind of pops out of, like it flies out of your brain. It does every year. Gotta plug in that dy dx. But kiddos, we know how to simplify a complex fraction. Multiply top and bottom by y over y. It's the simplest way. Don't forget to distribute, right? So you end up with negative y squared.
Plug in.
The y's just cancel. Oh, I forgot we were plugging in, so I'm simplifying. We could have just plugged in too.
No, simple, just simple. Okay.
The y's cancel, negative x times x, negative x squared, and then y cubed. Now Tyler did make a good point. He was like, why don't you just plug in? We could have plugged in numbers way earlier. Now we did have to find the second derivative, but then we could have figured out the first derivative in numbers and then plugged it in numbers. We could have plugged in numbers here as well. But eventually you have to simplify the complex fraction anyway. Guys, this is just my such that line. Remember my such that line just means like, hey, it's time to plug in. So plug in 6 and plug in 8. We end up with negative 8 squared would be negative 64. Minus 6 squared would be 36. All over
216.
8 cubed.
I
I think you did 6 cubed.
did.
8 is the y, right? You guys wrote down the question?
That's all I got.
I struggle.
Whatever.
8 cubes, so that'd be 864, 64, that's
Yeah.
512. 512, yeah. Now, pause. Remember, on the AP, there's a non-calculator section. If you needed to, could you do 64 times 8 old school?
Yeah,
And say, hey, it's 32, and then carry the 3, and then 48 plus 3 is 512?
yeah, but that's weird.
You might need to do it on the AP, just want to make sure you guys are good. Negative 64, negative 36, isn't that negative 100?
Negative.
Oh.
Why be 110? Because the ones. Oh no, wait, never mind.
90 and then, yeah. So negative 100 over 512, okay, this is taking forever. What
Yeah,
does that reduce
simplify
to
that
be?
without a calculator.
Oh, shoot, that's,
Well, I mean, just looking real quick,
Okay, yeah.
right, it wouldn't be C or D.
Whoa, you can't
25.
do
Wait.
elimination.
Wait, why?
Yeah, because there's a negative.
Oh yeah, okay.
So cross off C and D, that's pretty obvious.
25.
And then I see 128, so you just have to think of, okay, well, 128 goes into 512 4 times, so then 4 goes into 100.
And you have to just guess on the remaining two.
Wow, this was the biggest workspace and there was 3 problems.
Dun, dun, dun. Now, question, which one was probably the longest though? The second derivative, yeah.
Those take
As far as I know, with the AP, there's almost always something like 86. If you want to put a star by it, it's not a bad idea. There's almost always at least one problem like 86.
Just one?
Well, because there's so much in calculus, you can't, there's only 28 and 17, 30, 45 multiple choice total.
35.
Oh, that's
I mean,
not
that's a
very
lot, but.
For an hour and a half? Or,
Jeez.
Actually for 55 minutes, yeah, hour and a half
How
total.
many have cubes?
6.
that's not
All right,
better than.
And I have the French exam after.
kiddos, any other questions?
Too, Sean.
Any other questions on these ones? All right. Does anybody have anything else on section 2.5 from them working over the weekend that we just really didn't make sense or didn't understand? This or that or the other?
Wait, everything on the board, did, like, can you take a picture of that?
I didn't personally, but some people did. Who got pictures of everything on the board on Friday?
Not me.
No?
I don't have one.
Okay, some period 6 people did. I have to remember who though.
Uh,
Some of you stayed behind and took pictures of it. Oh, you silly goofs. Really quickly though, I want you guys to go back in your notes to the last example that we did on the Wednesday?
Thursday.
Thursday?
We did homework.
This is the one that I did in 54 seconds and I got it wrong.
Oh, yeah, it's Thursday.
I did this
F
wrong.
minus.
Somebody already knows because I think I told them about it.
Yeah.
So anyone who doesn't know, can you see where I went wrong?
Find the
And
error.
quick hint, it was not in the calculus.
It's in the algebra, but wait.
It was not in the calculus.
Okay.
It was in the pre-calc. Pause. Sorry, that was yours.
Yeah, that's the right one.
Where did I go wrong? That's the right one. Lo siento. This is what's in your notes right now.
3 plus x as a power.
I made 3 plus x as a power of who? If it comes down right now, who is it a power of?
2x.
The whole thing. But question, was it the power of the whole thing? It was 2 to the 1 times x to the 3 plus x. What would need to be here to make this the power of the whole thing?
Parentheses around the whole thing.
So my 54 seconds, struggle.
So what would be the difference?
However, look at this,
The big difference.
right? This is what we got. And look at how similar it looks to what it really is. Wait, what's the difference? That's the same?
3 plus.
That's the same? What's the
2x.
only difference? Whoo! Whoo! Man! In your notes, you need to fix it.
So,
In your notes, you need to fix it. The very last example from section 2.5. You need to fix it. I'm going to show the correct one, okay? Here's the correct one.
yeah, but on an FRQ, that's like the difference between full credit and like
I'm
0
assuming this
points,
would be an
right?
FAQ. It's
Because
a multiple choice. It'd be right or wrong.
on a multiple choice, you'd probably still get it right because your answer is more or less identical.
I mean, because like you like.
Unless-
That's
no,
the whole
because they
point of the
probably
multiple
have-
choice.
yeah,
They
they
know
probably
exactly
have.
what mistakes you would make. So then check it, kiddos. In order to bring the 3 plus x down, which I had to do, there's no other way of solving this derivative without bringing it down with a log. I had to split up 2 times x to the, I had to split up with the product property. So I had to do addition of ln of 2 plus ln of x to the 3 plus x, then I was allowed to bring it down. Then I went ahead and did the derivative of the left side and the right side. Ln of 2, his derivative is 1 over 2 times 2 prime. Who's 2 prime? 0, right? It's just a constant. So the derivative is just 0. Yeah.
Why am I not allowed to just bring down the
Because it's 2 to the 1. If I bring it down now, I'm saying that it's 2 to the 3 plus x and x to the 3 plus x, which is false. It's just 2 to the first power. It would have to be written like, it'd have to be written like this for me to solve it the way I did. Yeah. Let me give you guys a second. I need you to go ahead and fix that mistake. We were supposed to do it on Friday and I don't know, I forgot. Period 6. I took a little longer. Probably took like a minute and 15 seconds and I realized my mistake. Struggle.
This is why the tortoise wins.
Sometimes.
What?
And in all honesty, in real life, tortoises doesn't always win.
Yeah, it's more like a
What are we talking about? Oh.
tortoise in reality.
But the tortoise does
usually wins.
have more perseverance, usually more
I think the
character.
tortoise like understands more.
Yeah, well, the tortoise fails the AP
than the
test, so.
Exactly, the hare just goes ham. Who wins?
The hare may only
That's
get like
why-
40%, but he still gets a good grade. Okay.
I'm gonna go ahead and delete this page
Should
real quick.
become a tortoise, a hare and a tortoise.
Good idea. How does that work?
Just get mixed
There we go.
as one.
Alright guys, you ready?
Great.
I love mixed.
Okay. Our goal today and tomorrow. Our goal today and tomorrow is to start section 2.6 so that we can finish it with the juniors on Wednesday, I think is what my calendar has. I'll double check the calendar tomorrow. This homework will not be due until Thursday, but, oh my goodness, you okay?
Don't die.
Okay. I am going to be giving back your chapter 2 test, your chapter 2A test tomorrow. And we might try to have like half of a work period tomorrow. We'll talk about sweatshirts tomorrow. So tomorrow's going to be kind of like a, you can be working on the homework from section 2.6 if you get a good start in on it tonight. Or even if you have a fairly good grasp of section 2.6. But you could also be working on corrections, because we'll be finishing 2.6 on Wednesday.
A lot of those.
So we will, tomorrow's going to be kind of our more chill day, which is a good day to have it, because it's also our barbecue day, right?
What?
So, the senior barbecue.
Ah.
Yes.
Don't forget the $6, y'all.
So would it usually be 7?
What's the dessert?
I think it's usually 7. That's the same thing at the snack shack, so it's a good.
I have no
It's a good
idea.
deal. And you get like Joe's, you get pumpkin, what did Katrina get? Scary Joe's? You get pumpkin Joe's, you can do pumpkin bowling for a prize. And you
Yes,
get,
I'm having gourd bowling.
and you get chips and you get a soda.
Gourd? Is it
Aw.
gourds or pumpkins?
The gourds are fun.
Yeah.
But those don't roll. They have the stupid stem on top.
Exactly, that's the point.
Okay, but what about the what about?
I mean, if they roll it this way, then that would be,
Just roll.
I probably shouldn't have rolled that.
Yeah, you
Don't
should
roll it that way, just roll it.
Stem like a nail inside or
Let's do it.
something, right?
Ooh, chocolate pumpkin face cookies with our signature vanilla bean ice cream. No, not ice cream, cream. Ice cream would be really good. Oh, but she got normal pumpkin Joes too. So good.
What are those? I don't
Okay,
know
so
what those
they're
are.
like Oreos.
They're like Oreos, but with amazingness.
Ah, they're
I see you
They're
are
Trader
okay.
Joe's Oreos. Wait,
I'm a fan of pumpkin almost anything, except for pumpkin pie. I do not like.
I hate pumpkin pie. I like almost anything pumpkin. Just
Like that's
it's like baby food.
that we're gonna
Pumpkin pie. Get out! This entire page is pre-cal, so I'm just gonna fill it in.
Yes, inverse functions, yes. Wait, do you just take the inverse of a function and then take the derivative? Or take the derivative and then take
Some
the
of them,
inverse?
like implicit, will be too hard to find the inverse before doing.
Oh, and then you have to derive and then take the inverse, or what?
You can either switch the x's and y's and use implicit. That's one way. Switch the x's and y's, just don't get y alone after that, because it's usually going to be too hard. Or there is a formula that you still have to learn because the AP loves to not always give you functions and make you deal with it other ways. So, you're gonna have to learn two ways. Switching to X and Y and using implicit is one way, where you don't have to actually find the inverse, because right now, sometimes it's gonna be too hard to find the inverse. But then there also is a formula that results from switching X and Y and solving for the derivative implicitly. But you're gonna have to understand, so I have some good examples, and that's why I'm waiting until Wednesday to do some of those AP practice problems. Okay, so all this is pre-cal, right? Inverses reflect across a y equals x. Remember the graphs, they flip across that diagonal line. You switch the x and y. In pre-cal, we would solve for the y. In calculus, it's usually too hard. It's usually too hard. You guys know the notation. What happens when you take the composition of a function and its inverse? Everything gets undone. No. All of the operations to x get undone. So 0 is not left, 1 is not left, x is left. So it means the range is switched to a point switch. If you guys notice, all these sections, chapter 2, the end of chapter 2, for exponential, for logarithmic, for implicit, we're doing pre-cal review fast, and then we're doing calc.
Yeah.
Alright. You guys ready?
No.
Well, depends on how hard this section is for me.
This section does not need to be hard. I'll put it that way.
It is hard.
I mean, it is hard.
I'm ready.
Oh. Yes.
What are we looking at?
It's just a little more review.
It is, oh.
Although you have to remember horizontal tangent lines. Oh, well.
Careful, not tangent lines. HLT, horizontal line test, like vertical line test.
I hated those.
Is, the snazzy word is invertible. The other way of saying it is one-to-one. But guys, remember, in calc we are very focused on derivatives. So we're not necessarily going to be testing on all this pre-cal stuff. There's just a few different times where it's useful, like down below. If we're talking about the differentiability of an inverse, this is where this comes in. Pretty important. If a function f has an inverse, if f is continuous, then his inverse will also be continuous. I'm just going to do one quick example over here. I'll use E and ln as an example. So here's my f, and here's my f inverse. If one is continuous, the other is continuous. However, for both of them, it's going to be on their domains. On their domains. Let me zoom in on the second page. I think we should all be on the second page by now. Because E and ln have very different domains. But they are both continuous functions, but only on their domain. Because ln's only good for x greater than 0. E's good for all real numbers. So they're continuous, but not necessarily on the same interval. If f is increasing, you might think the f inverse is decreasing, but it's not. It's increasing also, just at a different rate. It's increasing also, but at different rates. Now here's a question. Where would the inverse have the exact same slope as the y-intercept of f on f inverse?
Would it be at the same y value?
Same y value? Well, it's not going to hit that y value until over here, and I think it's going to be less steep.
It's not the same.
Remember, this is e to the x, and this is ln of x. Slope is the same thing as the derivative, right? So question, what's the derivative at this point on the original, which is, isn't that the point 0, 1? What's the slope at 0, 1 of the, well wait, just take the derivative of e to the x, which is? And then plug in 0. 1. Okay, so the slope at 0, 1, the derivative is 1, right?
Oh, it's at 0 then.
When will the inverse have the exact same slope?
1. When x is
You know, 1.
Yeah. Why does that make sense?
Because they look like
Or
the
can I
same.
do that a little bit better? Can I do that better? Or what's the derivative of ln of x?
1 over,
1 over
x.
And so when is 1 over x going to equal 1? When x equals 1. Okay. What do you notice about those points?
They look
Are they inverses of each
The
other?
slopes are the same,
look
but
at
what's
that.
true about the points?
Inverses of each other.
They've switched, right? They've
Oh,
switched.
shoot.
So then here's something crazy.
Excuse me.
If I know the original function, I can switch the point to find the slope. Or if I need the slope at the inverse, I can switch the point and look to the original. Now, here's the weird thing. Do they always stay the same? Kiddos, what is, oh, this is gonna get a little tricky. Okay, let's do it this way. What would be the slope at x equals 1 on e to the x?
E.
Yeah, because you plug in 1 to the derivative, and the derivative is e to the x. So m equals e. Question. That was the point 1, e, right? Okay. Where's the point e1 on the ln curve?
2 point.
Yeah, 2 point something and then 1, right here, right? Okay, is my drawing just really off? Those do not look parallel, do they?
No.
Question, what is the slope at E1? Think about ln.
1 over e.
It would be natural E. 1. Wait, how, it can't be 1 again. It needs to be 1 of 4.
1 over e.
ln of x has a derivative of 1 over x, plug in e, what would that be?
1.
Whoa! Wait a minute! Hold on, they're not the
So it
same.
was just the inverse.
1 was 1, they were the same. E and 1 over e, they're reciprocals. Guys, what's 1 over 1?
Oh, itself.
This is the only one that will stay the same. All the rest, they are going to be reciprocals.
Oh, it's Monday.
So the points split, I know. For the chapel and the underclassmen.
Where's chapter?
So wait, pause. Do you guys see the original and the inverse? Okay, do you see how their points switch?
Yes.
And are their slopes related?
Yes.
But are they always the same? What is the relationship? Reciprocals. You see it?
So, yeah.
Okay, let's come back. So Beth, man, I went way off on a tangent.
Yeah, it's funny.
But
Yeah.
anyway, coming back.
Okay.
Yeah, thanks. It's a Monday, you guys didn't respond. It was really lame.
It was good, it was good.
F inverse is increasing. And if F is decreasing, F inverse is decreasing. However, not at the same slopes. Long story short, not at the same slopes. The slopes will be reciprocals.
With D.
Yeah.
After D, can I go to the after?
Yeah. F is differentiable at x equals c. If F is differentiable, F inverse is differentiable also, except it's going to be at y equals c, because the x's and y's switch. So if it's when x equals c on 1, it's going to be when y equals c on the inverse. However, there is one quick little change. If the slopes are reciprocals, question, what is the original's derivative not allowed to equal? If the slopes are reciprocals, what can the slope of the original not equal?
Oh, 0.
Yeah.
Because it'd be 1 of this.
If the derivative of f is 0, I'm going to have troubles on f inverse because it's going to be 1 over 0. So if the derivative of the original is 0, I'm going to have problems on the other, because it's going to be 1 over 0. All right, speaking of that whole 1 over thing, I think there might be some sort of formula that has something to do with 1 over if the slopes are related by this reciprocal relationship. So maybe like 2 more seconds. We should almost have it. I think I'm going to leave off this next page. We might just skip this next page altogether.
Yeah. Let's do.
You can look at it. I don't really think I want you guys writing it down. But the long story short of it is, if we were to take something like, oh, this is going to be a mess. One branch of a parabola has been shifted up that has a horizontal tangent line at 0. If we were to flip that for the inverse, what's going to be going on at, yeah. So even though this one is going to equal 0 on the original function, on f, there's going to be a horizontal tangent line. This one, obviously the x's and y's have flipped, but m is now going to be undefined. Why? Because it's 1 over 0, because it's the reciprocal. And that's going to be of f inverse. So I was just saying the horizontal tangent lines of one become vertical tangent lines of the other. So, but you guys know that 1 over 0 doesn't exist, so hopefully that'll just naturally occur. All right, here we go. Here we go. I want you guys to go ahead and write down an equation of a tangent line. We're talking about the tangent lines to the original. We're going to find the rule that you need to know for the AP. Remember, I also said you can switch the x and y and solve implicitly. But the AP sometimes forces your hand and you have to know the rule. So as you guys are writing down, you have the function f of x and you have the point AB. You have the function f of x and you have the point AB. You have the function f of x and you have the point AB. So I want you guys to think about, okay, what's missing in the equation of the tangent line? What spaces are there? What's missing? What spaces are there? And how would you fill them in? What are we missing in the equation, guys? The point and the slope. Well, we have everything for the slope, but don't we need an x1, a y1, and then an x1? Or a and a b and a, oh, hey, what's going to get plugged in? A is the x, right?
Yeah.
B is the y. And we find the derivative at a. Does that make sense from our forever curve? Okay. What happens, though, when we go to look at an inverse?
Oh.
The points are switched.
Do we-
Yeah.
And also b is the f of b.
So another way of thinking about it is you take the equation of the tangent line and say, technically, don't switch a and b. Not technically. Technically, who are you supposed to be switching? So switch the y and switch the x. So it's going to be x minus b, which if you think about it, oh, yeah, the b is an x now. Because for the inverse, you have the point b, a, right? Equals f prime of a times y minus a. Now hold on, this tangent line is all messed up though, because tangent lines are supposed to have y alone, right? So let's just take the tangent line and let's solve for y alone in the tangent line, which we can do a lot easier than getting y alone in three functions. So if we were to get y alone, kiddos, what's something we would do? There wasn't a page of notes, David, but we basically said, oops, that it's not super important, so they didn't write it down anyway. You just peek at it, but otherwise we're good.
Very good.
So we need to get y alone. What we've done is switch the x and the y in the tangent line. So we're going to divide both sides by, you guys okay with dividing by f prime of a? So now you get, can I rewrite it a little bit to make it better? Y minus a equals 1 over f prime of a times x minus b. Ooh. Ooh. Isn't that a tangent line? And isn't that a tangent line that's plugging in? B for x1, A for y1, but what is weird and what is different?
The slope is resistance.
The slope, exactly. The slope of the inverse at x equals b is 1 over the original's derivative at a. So it's the reciprocal of the original slope when x was a, which is what we saw in the graphs of e to the x and ln of x. The x's and y's switch. So when they're asking for the slope of the inverse at x equals b, if you want to see the notation for that, it's kind of messy. It's really actually quite disgusting. F inverse prime at b. Now, can you tell what one of the trickiest things is going to be with this formula?
Plug it in.
Yes, because they say, I want it at this. But you need to plug in that.
Oh, because when you plug in A, it gives you.
When you plug in A to the original, it gives you the spot that matches where the slopes are reciprocals. So I'm going to try and help you with that whole process in the sense of them giving you one number, you have to plug in a different number. But here's the relationship once again. They're going to give you, for the original, they're going to give you the y of the original. They're going to give you the y of the original, and you need to plug in the x of the original. They're going to give you the y because the y of the original is the x of the inverse. Anyway, this is not your forever card. If it was, we might cry just a little bit. But this is why the rule is what it is. Here's your forever card. Let's simplify this, okay? I'm going to actually put two different things because they can give it to you two different ways. And guys, this entire card really is for helping you on problems where they force your hand to use the rule. Okay, let me make this a little bit smaller, that way it fits. Let's move you over, let's move you over. They can give it to you two different ways. The weird thing is if they're asking you for the derivative of the inverse, they're going to call it a, which is a little bit of a struggle, but that's okay. We just know it switches.
What time do we get this?
53? There's two different ways of writing the rule. One way is to say 1 over f prime of b over f prime of b. The other way is saying 1 over f prime of f inverse of a, because f inverse of a is b. So there's two different ways of writing it. Basically, if they give you the direction to find the inverse prime of a, you have to go look at the inverse point if they give it to you and plug in b. Or if they don't give you the inverse point, go look at the original and say, uh-oh, a is the y, I need the x to be b. So there's two different places that we can find that b. If they give you an inverse point, it's in the y spot. If they give you an original, it's in the x spot, which is kind of weird. I might add a little bit more to the forever card. Let's not necessarily mark the forever card today. But let's see if we can get, if I can, one example in. Can I? Yeah, let's see if we can get one example in before we end. So, if they want f inverse prime of a, another way of writing it is they want f inverse prime of, who's a? 1/2. I'm going to do 1 over f prime of, here's the weird thing, to solve for him. I'm not going to finish it, I just need to show you to solve for him. I go to the original and I say, wait a minute, this is the x of the inverse, which means it's the y of the original. And so you have to figure out when is sine 1/2 in this interval. You guys can go and pack up, it's okay. When is sine 1/2? It's going to end up being at pi over 6. So you're going to have 1 over, who's f prime? Cosine. Pi over 6, which is going to be the same thing as 2 over root 3. Get out of here, cool kids. It's on the video if you want to check it out. We will have a work day mostly tomorrow, but we'll probably do a couple more examples first.
Oh.
Let me pass it for you.
Oh, no.